We explore distant planets, but know so little about our own oceans. Here, even the largest creatures have been overlooked, like the giant manta ray. They're called manta from the Spanish for cloak and devilfish for their horns. And while some stay close to favourite sites, mysteriously others vanish for years. Now a group of scientists is on a mission to reveal the life of this intriguingly smart creature.
Everything from now on will be new. We know so little that we're guaranteed we're going to be discovering new and exciting things pretty much every time we come out on a field trip.
Exploring manta hotspots around the world, they find astonishing behaviour. From these rarely filmed mating trains triggered by the full moon, to one-of-a-kind feeding frenzies that only happen once a year.
Anyone who's ever dove with them, they'll come up raving about the experience. I get extremely excited. That's why I love this project. Every time we get a manta ray coming in, it is such an exciting experience.
With a wingspan reaching 7 metres and weighing up to 2 tonnes, manta rays are breathtaking animals to encounter. These mesmerising giants live in tropical waters around the globe, but we're in the dark about how many there are, where they go to feed, mate, or even give birth. In Australia, sharks and rays are common along the east coast, but manta rays are much more elusive. They appear and disappear with unfailing regularity, and that's the first challenge for Project Manta's team.
The only thing that we do know for sure is that the manta rays are seen here at North Stradbroke Island for 6 months of the year, and then they're not here. But where do they go the rest of the time? So if they are moving or migrating vast distances, are they actually going across international boundaries? And the reason we're concerned about that is because our nearest neighbors to the north actually have a targeted fisheries for manta rays. So that's one of the big questions. Is our population potentially moving into a danger zone?
Worldwide, mantas are classified as near threatened. And in Australia, like almost every other country, they remain unprotected. But to protect an animal, first you need basic information about its life. One of the world's few manta hotspots is the Great Barrier Reef, which stretches for 2,000 kilometres along Australia's east coast. Hardly anything is known about its manta population, but that's about to change with Project Manta, based further south on North Stradbroke Island. It's taken her 3 years to drum up finance and support. Now, lead scientist Dr. Cathy Townsend is ready to head into the field. Closely by her side are biologist Lydie Couturier and ecologist Fabrice Jan. In the coming year, they'll lay the foundation for the first manta census.
It's a multidisciplinary team that we've brought together, and that's what makes this particular study very unique. It's a group of ecologists, behavioral specialists, oceanographic specialists. Because it is such a large question, you can't work within just one discipline.
To find out why and where their population travels, the team must be able to recognise individuals, and they tell the mantas apart by the distinct black markings on their white underbellies. These markings are like a human fingerprint. No manta shares the same dots and spots, and each has its own personality.
Some animals are extremely interactive. They'll come and stay with you for a full, 50, 60-minute dive, through to the other opposite extreme, where you've got ones that are not the least bit interested in you and are just cruising past. And we've got one little one that we call Curious, who always spends a lot of time with us. And then there's another one we call Speed Racer, and he never sticks around, he just goes.
So where do Curious and Speed Racer go during the course of the year, and why? What dangers will they face, and how do they spend their day-to-day lives? Most of the time, mantas seem to travel alone, but there's at least one spot where they do hang out together. Coral reefs are like bustling high-rise cities, and the busiest corner on the block is the cleaning station. It's run by a crew of little striped cleaner fish that service a never-ending queue of eager customers. And when the mantas descend, every bit of help is needed. As soon as they arrive, all kinds of small fish hurry in. To them, a manta is like a giant plate to scrape clean, and they lose no time in picking off parasites and dead skin. The manta itself drifts slowly around the station, and it might stay for many hours while it's pampered and generally spruced up. But they can't stop altogether. Like many sharks, mantas are negatively buoyant, meaning they sink if they don't swim. Often they go in circles, queuing patiently until it's their turn to drop in. Most likely, cleaning stations also act as social hubs and involve a certain manta etiquette. But for the moment, too little is known about their behaviour. There are also paramedics at hand, ready to clean up scrapes and wounds from shark bites. The moon wrasse specialises in removing infected flesh, and this manta's bitten tail is clearly still tender. Cleaning stations are the best spots to closely observe these ocean wanderers. But the big question is, where do they go between their grooming sessions? This is where Project Manta will be breaking new ground. It's June, the beginning of winter, and something strange is happening on Australia's east coast. At North Stradbroke Island, or Straddy as it's known locally, all the mantas have disappeared. Yet 400 kilometres to the north, around Lady Elliot Island, their numbers are rising. Is this where the missing mantas have gone? Over the next 12 months, Cathy Townsend and her team will be closely monitoring the mantas around Lady Elliot, the southernmost point of the Great Barrier Reef. Mantas visit the island year-round, but their numbers more than double in winter. To find out whether Curious and Speed Racer have pitched up here, Cathy must open a register.
The very very first thing we need to do is to go out there and identify as many individuals as possible. And so what we do is we take a photo, we compare that with our database to see if it's one we've seen before or if it's a new individual. And the reason we're doing that is we want to try to get a bit of an idea as to what our total population size is. What about this one?
Oh, yeah.
Logging every dot and spot, they've already identified over 100 new mantas in just 2 weeks. But the most exciting discovery is finding an animal at both Stratty and Lady Elliot.
Was it? Excellent. Look, she was down at Stratty 3 months ago, and now she's up here.
Traveling around.
Yeah, I better write that down.
The first matches suggest a link between the two islands.
Excellent.
But to be sure, they'll need much more data. And that's difficult to get.
Particularly when it's from Stratty.
With the photographic ID, basically you have to have a diver in the water to be able to take the photograph. Of course, there's limitations to that. Divers can only go a maximum of 3 hours out of any day. Acoustic listening stations get rid of that problem. It's like having a diver or somebody there recording 24 hours a day, 7 days a week.
To get this round-the-clock surveillance system up and running, the team needs to set up 2 parts: acoustic tags to be attached to the mantas and underwater listening stations to be positioned around the reef. Encouraged by their first photographic evidence, they go in search of the best sites to place their listening gear. The station's anchored about 25 metres deep, and from down here, it will spy on the manta's comings and goings. This radio receiver can pick up signals from up to 500 metres away, and with 5 of them strategically placed around the island, there's good coverage of where the mantas are likely to be. When a tagged animal comes into range, its every move is recorded. This will reveal for the first time where the manta goes, as well as when and for how long it visits certain spots. Details that can't be obtained from photos alone. But now comes the more challenging task, attaching the acoustic tags. And to be successful, the team has to work closely together. They stay within eyeshot of each other so that they all target the same animal. Luckily, this cleaning station is already busy. Now they must act quickly. Before Fabrice can free dive 20 metres down to deploy the radio tag, Kathy and Lydie have to get clear ID shots of the underbelly. Later, they'll match this individual manta with the tag's unique radio signal. All clear for the first tag. One down, another 11 to go. Although the tags startle the animals, they're not harmed and all quickly return. With listening stations in place around both Lady Elliot and North Stradbroke Islands, they should soon detect the manta's first migration route along the Great Barrier Reef. Sharks are some of the most ancient animals on the planet, about 400 million years old. They're the ancestors of all rays. In fact, rays are basically flattened sharks. Rays evolved in their own right when they found their niche away from open water and adapted to live and feed close to the sea floor, like the infamous stingray. In self-defense, it stabs an attacker with the potentially deadly barb on its tail. Mantas are the most recent rays to have evolved, probably from stingrays, but they've lost the stinging barb. Having gone back to living out in the open sea, they now rely on size and speed for defense. And despite their devilfish reputation, they're harmless to us humans. Biologists first described manta rays more than 200 years ago, but it's the latest manta discovery that's rocked the scientific world. There's not just one species, as was long thought, but at least two. One of them, a giant ocean voyager. This truly gigantic ray can span 7 meters from wingtip to wingtip. That's almost double the size of its smaller cousin. And their lifestyle also sets them apart. This larger species seems to cross the world's oceans, while the smaller reef mantas appear to stick closer to the coast. Physically, these oceanic mantas are sturdier, with more pronounced body markings. But most tellingly, they're the only ones with a small bump on the base of their tail. Inside is the remnant of a non-functioning sting, a reminder of their family tree. And though not much is known about mantas in general, even less so about this rare giant. Mexico's remote Revillagigedo archipelago is one of the few places where they're seen regularly. And there's only one scientist with long-term research on this newly confirmed species. American marine biologist Dr. Robert Rubin has been working with oceanic mantas for almost 30 years. He's catalogued more than 300 animals. A few he still spots after 25 years. And it's not just their size that's so impressive.
Large manta rays seem to be extraordinarily intelligent. They show characteristics that we equate with intelligence. One of them, of course, is curiosity. That's one of the things that we assess in people that are bright. They're curious about almost everything, and that seems to be the case in large mantas.
These giants readily interact with divers. They seem to wait for new playmates. And there are further clues to their smarts.
The brain is disproportionately large when you compare it to their body size. And it's so large, as a matter of fact, that it compares favorably with some mammals of that size. And that's a very unusual finding for a fish, and particularly for a shark-like fish that is thought to be very primitive.
Primitive they are not. And over the years, Dr. Rubin's tagging studies have revealed more startling facts. Oceanic mantas travel much further and faster than assumed. One animal covered a remarkable 2,000 kilometers in a week. That's 3 times faster than the great whales on migration. They also dive much deeper, down to 500 meters, and can do so in quick succession. It means they can change rapidly between warm surface waters and the chilly depths. And that's thanks to a special brain heater, which keeps their large, complicated brains alert, even when the water temperature drops dramatically.
Their brains and other aspects of their biology suggest that they are extraordinarily advanced and compare favorably in many ways with the highest evolved organisms on the planet, which is mysterious beyond belief, charismatic beyond belief, and of course, they're spectacularly beautiful.
But these mystifying giants are far from safe. In the wild, only large sharks attack them, but that's not their greatest threat. Fishing nets are notorious death traps, and manta rays have long been accidental victims. But in recent years, the situation has changed alarmingly. Now, mantas and their smaller cousins, the mobula rays, are targeted directly by commercial fisheries in the Pacific and Indian Oceans. Overfishing has put a price on almost every remaining creature. While most are exploited for their meat, some are slaughtered for only small body parts. The ongoing demand for shark fins has already pushed their populations to the brink, and rays could face a similar fate. Mantas are primarily caught for their gills. They're in rising demand on the Asian medicine market, leaving their future hanging in the balance. Conservation relies on strong data, and back in Australia, Project Manta's focus turns to the manta's diet. Paradoxically, the biggest animals in the sea tend to eat the smallest, and like many whales, manta rays feed on plankton, tiny organisms that drift in the ocean currents. Using their unfurled lobes to funnel more food into their mouths, mantas can consume a lot of plankton. Estimates go as high as 27 kilos a day. The question for Kathy and her team is whether it's food that lures mantas to Lady Elliot Island in winter. To understand what's floating in the water, they take samples everywhere the mantas appear, before, during, and after feeding, all year round. And this study is not only about food, it's part of a much bigger picture. Plankton is highly sensitive to rising water temperatures, so it's an early indicator of global warming.
Plankton is one of those things that's predicted to be heavily impacted by climate change. And if you start messing around with the food source of the animals, then the reality is that it's going to, one way or another, also affect these large-bodied animals. So manta rays, if they're almost like the canary in the cage, as far as climate change is concerned, as to what is actually going on up and down the east coast of Australia.
To recognise change, they must understand what drives mantas in the first place.
Looks like there's a larval fish here too. Right here.
One of the big questions within Project Manta is where are the manta rays moving to and why are they moving? And the two main reasons that a lot of these megafauna animals like manta rays move is either for reproduction or because of food.
Project Manta's food critic is one of Australia's leading plankton ecologists, Dr. Anthony Richardson. With his help, Lydie and Fabrice will try to figure out which plankton the mantas are after.
Hi guys. How are you? Good.
There are two types of plankton: photosynthetic organisms like algae, the phytoplankton, and tiny animals called zooplankton. And it's zooplankton that mantas feed on.
With our sampling that we're doing, we're trying to look at the species composition of the plankton in the area, how it changes through the year, and see if we can match up when the manta rays are coming to these different sites.
Studying zooplankton is like counting grains of sand. They're the most abundant creatures on Earth, the all-important base of the ocean's food web and a sure sign of its health. But which of these alien-looking creatures do mantas prefer? Early results indicate they like the larger zooplankton, the shrimp-like creatures with their rich, oily bodies.
I think if you look around the world's oceans, the areas where manta rays are aggregating are likely to be areas of high zooplankton abundance. The animals are sort of the optimal plankton samplers and can give you an idea of where the hotspots for zooplankton are.
And there's one place that must be the world's hottest spot for both plankton and mantas. Lying barely above sea level, the Maldives string together almost 1,200 coral islands. They're home to the largest known population of manta rays on the planet. Between 6,000 and 7,000 mantas live here year-round, and one scientist has already identified over 2,000 of them. In the last 6 years, marine biologist Guy Stevens has discovered more than just a staggering number of rays.
Welcome to the Maldives.
Thank you very much. It's great to be here.
The start of the monsoon season can trigger a one-of-a-kind manta frenzy that Kathy Townsend has come to see.
Okay.
Nice to meet you.
It's only days away from the biggest tides of the year, and things are beginning to stir in a small underwater bay called Hanifaru.
Hanifaru is the only place we know about in the Maldives and in the world, as far as I know, where really large numbers of manta rays aggregate to feed. And when tide and lunar cycles all come together, you can have a recipe for just a spectacular feeding event.
The Maldivian mantas are the same species of reef mantas as in Australia, but when it comes to food, they're worlds apart. Hanifaru Bay is no bigger than a football field, yet it's revealed to Guy more about manta feeding strategies than any other place. When incoming tides sweep in plankton-rich waters, growing numbers of mantas form feeding chains. Like in Australia, they often skim along the surface, filtering the tiny animals through the gills in the back of their mouth. But as the tides increase, they do something very unusual. They feed on the bottom of the bay. Hanifaru is a dead-end street for plankton. Trapped at the end of the bay, it sinks to the bottom, and the mantas have learned where to catch a mouthful. And when they hit an especially dense plankton patch, they behave in a way Kathy's not seen in Australia. They perform a food ballet, backflipping or barrel rolling on the spot to gulp down as much food as they can. Swarms of zooplankton are bouncing around everywhere. But is it the sheer amount or particular species of plankton that attract the mantas?
Okay, Katie, 5, 3, 1. Yeah. 5, 4, 6. Yeah. Okay, you ready, guy?
Okay.
While the search for the manta's favourite food is taking shape in Australia, this is the first time Hanifaru's plankton will be put under the microscope.
It makes common sense that when there's more plankton, there would be more mantas, but we really want to find out what it is that creates the plankton concentrations in the bay and actually show the composition of the species of plankton that are there, the concentrations, and how that changes over time is really important to understanding how the whole dynamics of the bay itself work.
Pull it in.
And the dynamics are amazing.
Pulling in.
Samples taken at various stages of the tide reveal the most dramatic changes Kathy has ever seen.
You can definitely see the differences in the sample straight from the very beginning. You can see the different levels of plankton as you go through the tide cycle. You can see that the color changes because the zooplankton community structure is changing as well. And you can actually see that visually just with the naked eye, even before you've even started looking under the microscope. So it's really exciting. This is really cool.
But the coolest thing is about to happen, and it's unique in the world. The highest spring tides have arrived in Hanifaru, flushing enormous amounts of plankton into the bay, and with it come the manta rays, hundreds of them. The plankton's so thick it's darkening the water, and the mantas are whirling and twirling in every direction. The feeding frenzy has begun.
If you're in the middle of all of these feeding animals, your jaw kind of drops. You really don't know where to look. You're surrounded by so many animals that are, flipping and turning and sort of streaming past you in columns of 20 or 30. And it's just something which is complete chaos at times.
Then, right in the middle of this apparent chaos, the mantas begin something astounding, and it can only be seen a few times a year.
Big aggregations of manta rays will actually form a spiraling vortex of individuals, which almost looks like an underwater cyclone of manta rays. And this is a really spectacular event. And if you're a diver and you're positioned on the outside of this feeding mass, you can feel the current sort of pulling your body in towards the feeding animals. So they definitely generate their own current by feeding in this way.
The cyclone they create draws in even more food, and by joining forces, these Maldivian mantas have come up with a cunning hunting strategy, a phenomenon that's not been reported from anywhere else. Just when Kathy thought nothing could top the unfolding drama, another giant appears. Gulping down gallons of the plankton soup, a whale shark quietly joins the feast, almost dwarfing the large rays swirling around. And to see two whale sharks together is extremely rare. These incredible events at Hanifaru Bay make it one of the world's great natural wonders. Within an hour, the tide turns and the mad rush is over, just as quickly as it began. But for Kathy, the magic will last a lifetime.
The Maldives are amazing for mantas. This has been by far one of the most amazing experiences that I have ever had. And it's quite funny now. I think I shall go back relatively blasé when I see one animal now after having experienced the chaos of 150 animals plus a whale shark. It's an amazing spot. And it needs protection.
So could similar frenzies secretly be happening at the Great Barrier Reef? Now Project Manta is fired up to figure out their own population dynamics, and each piece of new data helps. Lydie is using a camera with laser beams set 20 centimetres apart, and for the first time she can measure individuals. This will not only give her the size of an animal. Over time, a series of these photographs will reveal if and how fast this manta grows. Ultimately, this will allow the research team to estimate the age of an individual and the age range of the entire population. To work out the population numbers, they must identify mantas from hundreds of new pictures. When they started out, they knew only 20 animals. But less than 1 year into the project, their database has not just grown, it's increased 20-fold. They now have over 400 individual rays on the books. Much of that success is thanks to Australia's dive community. Called up to send in photos they've taken up and down the East Coast, the divers' snapshots have already led the team to some significant discoveries.
Previously, the largest distance that this species had been recorded in moving was 390 kilometers. That's about the same distance as Lady Elliot to North Stradbroke Island is. And now we're actually starting to get some photographic images that are coming even further south. So we've had 3 or 4 animals from Byron Bay, which is about 500 kilometers between Lady Elliot Island and where that is down south. So we definitely have broken the world record as far as distance is concerned for this species.
But there's a flip side to this record. If animals travel 500 kilometres from further up the coast, they could head straight into the danger zone of targeted manta ray fisheries in Southeast Asia. It's a serious threat to an animal that matures late in life, has few young, and lives a long time. One of their rare black males, called Taurus, was photographed 25 years ago, already fully grown. Lydie can now confirm his identity, making this their first official record of a manta being at least 30 years old. But they've yet to find out where the old-timers travel.
Okay, Lydie, shall we download the listening station?
They should get new clues from the mantas they equipped with radio tags 9 months ago.
All right, here it comes.
If the tagged animals show similar movements, it could lead them to the main artery of manta migration that connects their feeding and mating sites.
Next, retrieve data.
But the emerging data tells a surprising story.
Oh, and somebody else.
That's exciting.
The really amazing thing about the animals that we acoustically tagged was the fact that the animals are so individualistic. We had one in particular that stuck around the island pretty much the entire time. And we had other animals that we tagged them, and then they disappeared, and then we saw them again months and months later for a couple of days, and then they took off again. You would expect animals to sort of have a similar pattern, but these animals are definitely doing their own thing.
And with the manta's unpredictable behaviour, it's proving even harder to find and protect their key migration routes. But large animals only move for 2 main reasons: to feed or to mate. And it's the mating that Kathy hopes to see in Yap, a tiny island state in Micronesia. Along its faraway coast, the manta's mating season has begun. Yap still maintains many of its cultural traditions. Yet for mantas, it's the most progressive country in the world. And that's mainly due to one man. He's the Manta Man, local naturalist Bill Acker. In Bill's adopted home, many lagoons are framed by extensive mangroves, the only known manta nurseries, but they're too entangled for diving. What put Yap firmly on the global manta map is the protection the entire country has granted its devil rays.
So you were telling me that this whole area is a manta sanctuary, is that right?
Yes, all about the manta rays and their environment. That's what's very important because, see, if you didn't have the environment, then people could do things in the mangroves. They could cut down mangroves. They could do things on the coral reef. But because we've included their environment, that just as broad as can be.
Anyone harming mantas or their habitat faces 6 months in jail and a $1,000 fine. While the impenetrable mangroves keep baby mantas safe from humans and sharks, the wide channels in the lagoons are where their parents hang out. Bill estimates about 100 reef mantas live here with no sign of ever leaving.
If nothing's going on there, then we'll slowly make our way with the current and we'll end up with a shallow cleaning station in that big rock.
Yeah.
And in February, the animals start to search for mates. It seems the approaching full moon triggers the courtship. Bill's been diving here for over 30 years. He knows the mantas by heart, and it doesn't take him long to spot an old buddy.
I believe the animals recognize us. I think they're very intelligent. When you're down with a group of people, they will go look through all the people, and then they'll actually come to us, dive guides, to myself, and you can see the eyeball looking you over, and yeah, I believe they know us.
And there's one manta Bill certainly knows well. It's Valerina, one of Yap's most noted matriarchs. With a distinctive V pattern on her chest, Bill named her after his youngest daughter, Valerie. That was more than 20 years ago, when the ray was already fully mature. Now Valerina is possibly in her 40s, and, like Taurus in Australia, she's living proof of just how old mantas can get. It's likely they can reach 50 years or more. Valerina is almost part of Bill's extended family, with a close bond between the two of them.
I think Valerina and him have a very special relationship. She started to recognize us and was coming in and having a really close look. And that's the wonderful thing about diving with the mantas. They do seek you out and have a look to see what you're doing, which is really quite unusual for a shark and ray. They don't generally tend to do that.
Large, laid-back females are easy to spot, but the males are a lot more flighty, especially during the mating season. So who's around for this year's pairing? Bill's Wall of Fame shows Yap's key mantas, and after a week of diving, he can single out a few familiar characters.
We also Blitz is another one that has two stripes.
Interestingly, Bill has catalogued 3 times as many males as females.
Different spotting on Ryan, and Ryan was one of them that we were seeing. And then what you got? What
Females possibly attract them to the area, and then the males start to line up, quite literally.
It's really interesting down and around here as well.
To watch these trains is really special. I mean, these are big animals. And then, of course, underwater, everything is magnified a bit, so they look even bigger than they actually are. And then when they stop all around you and start doing these dances, it's magic. So you have to just be lucky to be in the right place to see it.
With the full moon just past, the mood along the reef is changing. The mantas move differently. They're not simply cruising around. They're on a mission. A smaller male starts to shadow a bigger female, copying her every turn. Before long, more hopeful candidates join in. With the female in the lead, this rarely seen mating train is taking off, and the males try to outmaneuver each other to claim the prize spot closest to her. New males try to jump the queue, but it's the female who chooses her partner, and she comes up with a clever strategy. She derails the train and takes to the sky. Her suitors have to keep pace. Their careful order now thrown into disarray, they jostle for position. As it turns out, it's Valerina leading the runaround. It's a courtship dance Kathy's not seen before.
I've certainly seen in Australia the mating trains on, sort of more the single plane where they're moving around. But here they actually go right up into the water column. And yeah, it's very interesting to see how things differ ever so slightly within the manta populations, to see, is there a difference between the animals around Australia versus other places in the world?
The courtship can last for hours before the most persistent male might briefly mate with the female belly to belly. But often these trains dissolve before it comes to the final act. About a year after mating, she'll give birth to a single pup, something that still hasn't been observed, let alone filmed, in the wild. Back home, the first seasonal migration patterns along Australia's east coast are finally coming to light. Project Manta's focus is now firmly on Lady Elliot, which has emerged as a possible mating site.
Spotting for us. Yeah. Did yesterday. I'll keep an eye on you.
Over the last year, they've found more animals than expected, up to 300 in winter, and they've reached another important milestone.
Since we've begun, we now know, confirmed, that it is one single population between Lady Elliot Island and North Stradbroke Island. And that was one of the big questions we had when we started this. And as Liddy likes to say, Lady Elliot Island is the center of the manta universe. So yes, it is. It seems to be an extremely important site for the manta rays.
And the main attraction for mantas to visit this tiny outpost might not even be the mating. Satellite data shows it's around June that seasonal currents bring in plankton-rich waters, precisely when manta numbers peak. So they come in to feed. What's more, there's a striking similarity to the feeding frenzy in the Maldives.
The main species of plankton that manta rays seem to be targeting at Lady Elliot Island is the same species that we were seeing at the Maldives, despite that the Maldives is quite far away from where Lady Elliot is. So as far as the feeding ecology is concerned, that's a whole new chapter that we're now following along.
Every turn adds to the emerging picture. With Lady Elliot Island now marked as the first manta hub on the Australian migration map, Kathy and her team hope to soon find travel routes that will lead them to more feeding grounds or even manta nurseries. No doubt there are more surprises to come.
The first year has been an amazing step. We know so little about these animals that everything that you uncover leads you to more questions. And so Project Manta is definitely going to be happening for a very long time.
The more we discover, the better our chances of protecting these iconic and intelligent ocean wanderers. If we care to look after them, now